This is the textual code that we are going to use to implement our logic. At the top, you can see that I have included the liquid crystal.h header file in our C++ code. Here I have created an LCD object with the parameters 5, 6, 8, 9, 10, and 11. These are all the pin numbers at which the LCD is joined to our Arduino board. Here I've also created some variables. These are the components, and the values that are assigned to these variables are the pin numbers at which they are joined to the Arduino board. I've also created the sensor threshold variable, and the value that is assigned to it is 120, which is the maximum threshold limit. This is the setup code, and what this setup code does is basically defines the mode of different components of this circuit. And this is the loop code, and the code inside this loop is continuously executed. At the start of this code, I have defined a variable named analog value, and the value that is assigned to this variable is the value that is read from this smoke sensor. This is the if-else statement, and the condition inside this if-else statement is that if this analog value that is read from this smoke sensor is greater than the sensor threshold, then this set of code is executed. And here you can see that in this code, if the analog value is greater than sensor threshold, the red LED glows, the green LED turns off, and the speaker fires the alarm. The LCD, whatever message was there on the LCD earlier is cleared by this code, and then we are going to set the cursor inside this LCD at 0, 0. That means at the leftmost of the top row. Then we are going to print this message danger, and then there is a delay of 1000 milliseconds. That is 1 second. And again, this danger message is cleared from this LCD. And then again, we set the cursor at 0, 1. That is the leftmost of the second row. That is the row below the first row. And then again, we are going to print the message evacuate, and there's a delay of 1 second. If the analog value is less than sensor threshold, then the second code is executed, which is the complete opposite of this first code. You can see the messages here are safe and all clear. That means that the analog value is less than the sensor threshold, and it's actually the safe state. Now we are going to start the simulation. And as you can see that the message safe and all clear are being printed on this LCD. Now we are going to generate the test smoke by clicking on the smoke sensor. And as you can see, as I take this test smoke closer to the smoke sensor, as you can hear, the speaker has already fired the alarm. The red LED glows, and then you can also observe the message on this LED, that is danger and evacuate, which was set in the first block of code. And again, as I take this test smoke away from the smoke sensor, you can again see the red LED turns off, the green LED glows, and the messages on this LCD is safe and all clear, which was set in the second block of code. Thank you.